Mark Harvey. I'm a duty manager at OSRL and also lead of the OSRL low sulphur fuel oil working group. Firstly, a big thanks for giving me the opportunity to present to you this morning. My apologies that I can't be presenting live to you. I'm on annual leave this week. However, I hope this will make a good substitute, although quite how we're going to do questions and answers at the end, I don't know, but never mind. Now, I trust Steve Story will be present, and I'm sure Steve will be able to fill in the room. Okay, so amongst other things, we're going to be looking at the lead up to why LSFO is with us, and to the extent that it's here, the composition of it. We're going to look at the risk and the change in landscape that we're seeing. The IMRUS 2 project that we're very proud to be associated with, some of the challenges associated with response, and specifically OSRL's current progress with it and what we hope to be doing this year and going forward with regards to low sulphur fuel oil. So a brief summary of where we're at the moment. So as it says there, it's an alternative marine fuel, and I think it's fair to say that in terms of traditional oil that OSRL has dealt with, probably the nearest out of all of the alternative marine fuel oils that there are currently to what we're used to dealing with. And of course, the MARPOL Annex 6 requires vessels to limit their sulphur dioxide and sulphur trioxide emissions, specifically in emission control areas. And this entered into effect from 2020, right at the very beginning of the pandemic. So what is low sulphur fuel oil? So it blends of residual fuel oils and lower light fuel oils, typically shipped as bunkers as opposed to cargo. However, that is not a hard and fast rule. It can't always be produced blended at point of source, so there is a degree of transportation as well. We've not seen too much of that so far, but I anticipate that could easily increase. Just to make things a little bit more complicated, we understand there is a global feedstock shortage, so some of the already uncertain aspects relating to low sulphur fuel oil are actually even more unpredictable than they were. And then a quick definition. So ultra low sulphur fuel oil is material that has 0.1% maximum sulphur, whereas very low sulphur fuel oil has a maximum of 0.5% sulphur by content. So some of the risks that industry and OSRL are starting to find, it tends to be a lot more challenging and a lot more unpredictable to recover than standard, shall we say, clumsily traditional fuel oils and other oils. For obvious reasons, there's an increased usage by vessels, so we're seeing this getting more and more commonly in use across the world. And it's fair to say that low sulphur fuel oil in its use in vessels tends to require less modification work, so less expense to be able to allow a vessel to run more cleanly. So we're seeing that more and more. However, on the other side of it, there is a potential increased risk for blackout, so entering and leaving harbour, when some of the more traditional marine fuel oils are then switched over to low sulphur fuel oil. And I understand that there is at least one investigation going on globally at the moment about a potential incident that could have been caused by that switchover opportunity moment and problems that have resulted therein. So we're very, very glad to be a part of the IMRUS 2 project, and that's an EU funded initiative. It kicked off approximately January of last year and will be running to approximately December of this year, 2025. Specifically looking at the impacts and challenges associated with low sulphur fuel oil. But the project itself is all about trying to understand the material, trying to bridge some of the many gaps. And one of the things that we're finding out on this project is that for every question that gets answered, a new question gets posed. However, whilst we are finding it's an extremely challenging material to deal with, we are definitely moving in the right direction. And certainly we're very privileged to be associated as a company, OSRL, with some of the other stakeholders, which include many of the European and Scandinavian coast guards, with some armed forces in amongst there as well. And also, even though well outside of the EU area, one of the more recent global discussion panels, expert panels, actually had the US Coast Guard, AMSA from Australia, and members of the departments of Canada. So the good word is spreading. So in terms of OSRL and tiered preparedness, so it's fair to say that offshore containment recovery, shoreline cleanup, surveillance, modelling and visualisation, dispersants and in situ burning are some of the 5 areas that we would typically associate with this kind of activity in terms of dealing with material offshore and shoreline. However, starting from the far right, what we're starting to find, not just in MRS 2, but also just globally from a response perspective, is that there is very, very little evidence of success in terms of in situ burning. There are theories as to why this is, including the potential for there to be less volatility with low sulphur fuel oil. So therefore, that and other factors mean it's incredibly difficult, from the very limited testing that's been done so far, very difficult to get a decent burn established and then for that burn to continue. Similarly, for different reasons and with different aspects, dispersant usage, we're also finding that dispersants are nowhere near as reliable in common use as some of the other some of the more traditional oils that they're used on. We should, of course, always make sure, we shouldn't assume that we can't use dispersants. So the standard test procedure will be used, shaky bottle test, etc., but with a view to being ready just in case they're not likely to work. So that then leaves us with 3 realistic options in terms of strategy. So offshore containment and recovery, and we've touched upon some of the elements and challenges that are linked with that, and shoreline cleanup with surveillance, modelling and visualisation. So just being able to monitor and see what the situation is giving us. So in terms of containment, and this is a really good photograph from the OS-35 incident about 3 years ago in Gibraltar. If you look carefully at that photograph, you'll see there's a reasonable amount of oil inside that boomed area, but there's an awful lot of escape. Now that is generally considered to be a phenomena associated with low sulphur fuel oil, which is that traditional booms don't always contain low sulphur fuel oil as reliably as the more traditional oils would be contained. Bit of a mouthful, apologies, but you can see in that photograph there's some very pronounced escape, and it's generally accepted, well not accepted, but it's generally believed, I should say, that low sulphur fuel oil will make contact with a boom, and in some cases will actually start tracking downwards, following the outline of the boom, go around the other side and then off back to the surface and off to its escape. And this has been seen a few times on responses. It doesn't mean that we shouldn't use containment boom, doesn't mean that at all, but it does mean that we should be prepared for this situation to be taking place. And there are some discussions going on within MRS 2, which I've actually, which I'm promoting on leading, to look at what some of the options could be to try to help solve this particular challenge. So we've got a video here. Hopefully this will run, and my apologies if it doesn't. So a little bit of underwater filming, and hopefully what you can see is a challenge that this is actually forming. So on the leading edge of the spill that you can just see to the top, very top corner, the leading edge of that spill actually tucks underneath itself, as opposed to having a hard interface layer. It actually tucks in underneath itself and starts to layer itself. Now this is significant because one of the things that we're finding is that the thickest area of a spill within a boomed off area is quite often the leading edge as opposed to the apex. So something that we're mindful of. We don't have a clear, reliable assumption that that's always the case, but we are seeing that as increasingly as a phenomena. So another video here. So you can see as well, so you've got almost this kind of funnel-like area with low sulfur fuel oil. That brush belt type skimmer is actually very slowly running, but you can see it's largely clean. There is very little material being picked up by that, even though there's a huge amount of low sulfur fuel oil contained within that funnel area. So this is another challenge. We find that it tends to break off very easily, so that the almost capillary-like action on the surface doesn't seem to be followed in the same way that a traditional oil might behave. So this is yet another challenge that we're being faced. So this gives us a very concerning situation in terms of skimmer use, and what we're working on with the IMROS 2 project is seeing how some of the more commonly found skimmers globally by different manufacturers can be relatively straightforwardly modified to allow them to be more successful and more reliable in terms of low sulfur fuel oil. So Horten is a town in Norway where the Norwegian Coast Guard has one of their main bases, and they have an indoor covered test area where there's been an awful lot of testing carried on, but underway for the IMROS 2 project. And in these couple of images that you can see before you, what I'm hoping to actually show you is you can see that there are effectively puddles. Now, quite often we'll actually see low sulfur fuel oil with some water on top of it. Now, this is a consideration in terms of surveillance, modelling and visualisation. So just imagine in a wide area offshore with an awful lot of low sulfur fuel oil spilled. If you've got water showing on the surface, there's a very good chance that that could potentially be misinterpreted by an aerial surveillance flight. So any reflection such as that could easily make the operator think that that wasn't continuous oil, when in actual fact it largely is. So you could end up with estimates being slightly lower than they may actually be. But this does show some of the slightly stranger characteristics of low sulfur fuel oil. We have actually seen a situation similar to almost cotton wool balls on top of the surface, where it doesn't want to lie flat necessarily. And this is temperature and pour point dependent as well. So there are an awful lot of variables with this situation, as I'm sure you can tell. Now this is hopefully a video that you're seeing clearly, but if you could look very closely at, there's a swept area starting to appear. Now those brush paddles of that skimmer there, they're pulling in very little of that LSFO there, but instead you've got an almost perfect clean rectangular swept area where that's not been poured into the skimmer itself. And this is something we've seen on many occasions. There are theories about it being chain length, that perhaps LSFO has a shorter chain characteristics than some of the more traditional oils. and we definitely get a shear effect happening. So it's it doesn't want to pull oil into a skimmer. It's quite happy for that leading edge to literally just break off. That gets taken in, and then very little behind it follows suit. And hopefully that video was played, and that's made that a little bit clearer. So we'll see if this video will play as well. So this is another example of that, and you can see very, very clearly that that clean swept area. The oil, there's oil low sulphur fuel oil surrounding that leading edge, but it's just not getting pulled in, or at least very, very little. So the manufacturers that have now seen and experienced this, and there's about 5 involved in the project that have offered their products for testing, and during the test processes, they'll actually, in certain cases, actually make modifications that week to be able to test them, so you don't have to wait till the next test program. So hopefully that gives you a bit of an increased insight there into some of the challenges with recovery. So another video just showing one of the operators there physically manhandling it with a stick. Some very strange characteristics that we see. It doesn't want to tend to flow anywhere near as readily as some of the more traditional oils. So back in February of this year, we were able to attend Kotka in Finland, which was some primarily open air oil and ice testing, and there was a new manufacturer from Greece that offered some of their skimmers for testing with some modifications. They had quite a bumpy ride. I believe it was their first exposure to low sulphur fuel oil and their first exposure to ice. So they've learned a lot in the space of 2 or 3 days. But I absolutely commend all the manufacturers for being able to put their equipment forward and see what works and what doesn't. And they have learned an awful lot in a short space of time. And what we're hoping is by the end of the project, which is going to be November, December of this year, there's going to be some clear winners, so to speak, for want of a less clumsy term, to see which of the skimmers that are commonly available with some fairly minor modification work being required or add-on packages are going to be the most successful. So it may well be that OSRL may well be able to look at procuring one or more of those devices, ideally so they're not just for low sulphur fuel oil, but also to be used potentially for regular, more traditional oils as well. I think it's fair to say that it's absolutely not a consistently good news story, and this is some of the earliest findings from the first Imerus project. If you look at the color codings on this chart there, just to explain them, so in red, that means recovery devices that have achieved less than 5% of the manufacturer's recommended maximum capacity. There's an awful lot of red on that chart, and then go to the other end of the colour scale, so to green. That means that a particular device that's been tested has managed to recover 50% or more of the manufacturer's maximum capacity. So a single box of green, and although the bottom 2, the brush and weir skimmers, weren't tested quite as thoroughly on all the different oils, you can see there's an awful lot of red and very, very little green. So that gives you, just from some of the earliest findings of the Imerus project, the very first Imerus project from about 3 years ago, you can see that there's an awful lot of skimmers that have suffered that we're just not able to meet the challenge of low sulphur fuel oil. So you can see there's an awful lot of focus on that recovery piece on this Imerus 2 project as a result. So some of the progress that OSRL has been able to achieve so far. So we've carried out UK duty team training to make sure that those actually at the coalface, if you will, have the best possible chance of knowing what to do if they receive a phone call in the emergency operations centre, or technical advice in the field, or actually physically dealing with low sulphur fuel oil on a spill. The Imerus 2 project itself is probably well over halfway, probably nearer to 2/3 complete. We're already starting to identify some of the more suitable skimmers, but that is still very much a work in progress, and that's based on input from others that have dealt with different skimmers on low sulphur fuel oil spills. We've participated in 2 global expert panels. We've engaged with, amongst others, Rijkswaterstaat from the Netherlands, the Dutch Clean Water Authority, and IPECA. We've attended an alternative fuels workshop in London back in Q1 of this year, and internally there's been intranet articles published just giving updates about where we are on a project generally, so to speak, and about just sharing newfound information as it comes to light. And then planned progress, we're looking to put together a fact sheet just as a kind of black and white, if you will, very, very simple, straightforward guide for those needing the information, and a mobilisation guide for duty managers and duty teams. There is an awful lot of challenge involved with this, as I'm sure you've figured out already, and just trying to share that with those who need it. We want to, in conjunction with the IMRIS 2 project, have a list of recommended equipment, skimmers in particular. This is the first stage, and then booms as the second stage of that, and that's likely to be next year. And then we're also going to have a review of existing OSRL documentation, because it's such a rapidly moving subject. It's really, really important that as new facts and characteristics are found, we need to go back in history and make sure that what's been delivered previously, not just with OSRL, but globally, information that we use is still accurate and out there, and pertinent with the findings that we have today. And that's really important, that we can't just assume, because it is such a dynamic situation that changes very, very fast. So there you go. Hope that wasn't too long a session. And again, apologies I can't be there in person, but thank you very much for your time this morning. I wish you a good day. Thank you.